Have you ever felt like an AI system just has a mind of its own? One day it gives you one answer, and the next day you ask the exact same question, and you get something totally different? It can feel so unpredictable. Well, today we're going to crack open that black box and figure out why this happens. And it really all boils down to one critical idea. Retrieval is not memory.
Yeah, this is the million-dollar question, isn't it? Especially if you're working in a professional setting where you absolutely need consistency. You've got the same model, the same prompt, but the output changes. It can feel completely random. But what if I told you it's not random at all? In fact, it's perfectly logical.
So the root of all this confusion, it isn't really in the technology itself. It's actually in the words we use to talk about it. Our own mental shortcuts are kind of leading us astray. Look, we all do it. We say the AI remembers what we talked about yesterday, or that it's learned a new company policy. It just feels natural, right? It's a very human way to think about it. But this metaphor, this whole idea of human-like memory, it creates a fundamentally flawed picture of what's actually happening under the hood. This remembering idea is just a mental model, and they're great for getting started. Think of it like the scaffolding you put up around a new building. It helps you get the basic shape right. But for any kind of serious operational work, like a compliance audit or change control, you can't rely on the scaffolding. You need the actual blueprints. You need that formal, precise, mechanical description of the system. All right, so let's tear down that scaffolding. It's time to swap out that fuzzy metaphor for the crisp, mechanical reality of what's going on. And wow, when you put these two ideas side by side, the difference is just night and day. That flawed memory metaphor implies the model itself is being permanently changed, that it's storing things, learning, adapting. But the reality of retrieval is totally different. It's all about temporarily injecting text to give the model some context. And here's the crucial part. We're changing the system's input, not the underlying model itself. This is so important, I've got to say it again. Nothing is stored. Nothing is learned, and absolutely nothing persists beyond that single interaction. It's just like a calculator. You punch in 5 times 5, it tells you 25. But does it remember the 5s for the next calculation? Of course not. It just wipes the slate clean and is waiting for the next problem. So if it's not memory, then what is it? Okay, let's get into the actual mechanics. The whole magic trick hinges on this concept called the context window. And it's actually a beautifully simple 4-step dance. 1, your prompt comes in. 2, the system instantly goes and queries some external data source. Think of it like a document library. 3, and this is the secret sauce, it grabs the most relevant little snippets of text and stuffs them into a temporary digital workspace. That's the context window, right alongside your original prompt. And finally, 4, the model generates a response based only on the combined text that's sitting in that window at that exact moment. So the model isn't digging deep into some well of knowledge to recall anything. It is simply and very mechanically reacting to the specific text it was handed in that context window for that one singular interaction. And as soon as that response is generated, poof, that window is wiped completely clean. And once you really get that, it forces this huge shift in your focus. Because if the output depends entirely on the text that gets injected at that moment, well, then the real action isn't inside the model at all. It's in the system that's feeding it. This right here is the key. It's not a model issue. It is a system issue. The model itself is actually being perfectly consistent. The variable, the thing that's changing, is the information that gets fed into it by the retrieval system. And suddenly this opens up a whole new can of worms, a whole new world of things you have to manage. Your focus pivots from just the model to the entire life cycle of those source documents. You have to start asking questions like, is the retrieved information still relevant? Is it even accurate? And maybe most importantly, what version of the document is the system pulling from right now? And this brings us right back to where we started. By swapping our fuzzy, flawed metaphor for a clear, mechanical model, behavior that seemed completely unpredictable suddenly becomes traceable. Just picture it. On Monday, your prompt makes the system retrieve version 1.0 of a procedure document, and the AI generates an answer based on that. But then, on Tuesday, an engineer updates that document to version 2.0. Now, your exact same prompt goes out, retrieves the new version, and the AI gives you a different, updated response. See? It's not being moody, it's just pure cause and effect. So the ultimate takeaway is this. The mystery just completely vanishes once you understand the mechanism.
That behavior that seemed so inconsistent becomes perfectly traceable. You can point to the precise reason for the change. The source content was updated. The system isn't unpredictable, it's explainable.
And that leaves us with a pretty profound question, especially for anyone working in a regulated industry. If changing a source document has the exact same effect as changing the model's code, what does that mean for system validation? How does our whole approach to change control need to evolve when a simple content update can fundamentally alter the behavior of a validated system? That's the power of thinking like an engineer, not a psychologist.